Now that we covered Azure Machine Learning, I think one thing when you look at the Azure Machine Learning pipeline, as well as the whole workspace layout actually, is that it's very similar to everything we have learned right now, right? So far, when you look at Fabric and or the Fabric data pipeline or Databricks pipeline or Synapse Analytics pipeline, they all share the same characteristics. It's a diagram, it's a DAG, it's a directional graph where you complete the one job going into the next job, and they all start with data asset, and then goes through the transformation. Even transformation, for most part, it's the same. And the underlying technology can be Spark, can be Microsoft technology, Microsoft mQuery, going through different individual table processing and merge, join, union. Finally, going through the only difference between machine learning, the machine learning pipeline and the Fabric pipeline is that the machine learning pipeline has much more services, connectors, vision service, and vision service, AI service, speech service, as we just saw. And then there are like the more machine learning modules that you can utilize. So the natural question is, if we are, or if Microsoft is, try to create an integrated experience for data people. That data people includes both data analysts who use the Power BI and the traditional data transformation, and data engineer who use Spark and the data factory. How about the data scientists who utilizing those machine learning tool sets? And this is where Fabric data science comes into play. So data science is one of the experiences together with machine learning. So together with the data engineering and the data factory and the Power BI as a part of Fabric. It utilizes the existing Synapse data science, which is not too difficult because fundamentally the key here is still notebook, right? Data science is a notebook-based operation. It allows normal data science operations, and we all know that since notebook can be added into the pipelines, so you actually have the way of processing the same way that you would do in data engineering to create coordinations, orchestrations among different jobs to achieve more complex AI operation and machine learning operation. And but it does add some new flavor to it, some machine learning model experiment, and also there's environment. Environment is actually universal to both data engineering and data science, but environment is more important in data science world. So let's start with data science. It's the same data science notebook. It's the same notebook as what we have had in data engineering. But there is a difference. There are certain differences between the way data engineers use notebook and the way data scientists use the notebook. In general, data engineers use notebook for data processing, for large-scale data processing, and more those processing are more regular with in general with fixed patterns. We know where they are, we know where the source data are, and we know where what we are trying to get. So those are more predictable, volumes larger, and more on a scheduled basis. It's more automated, so that you won't see it once you set it up. You let it run on its own, and you don't see it until it fails. Data scientists more often than not does exploratory data analysis. This exploratory data analysis means you are bringing in data, you are analyzing that, and you come up with your own hypothesis, and you prove them wrong. For most part, it's proving them wrong, and sometimes if you are lucky, you get one right. So there are more interactions and more customization of environment. A lot of times when you create a new package, new data science project, you will need a new package and some other compute power, such as GPU or a large fleet of CPU. So you have the same need for Python and SQL power, but you don't really need so much orchestration or collaboration as in most part you are working on your own, but you do need DevOps because your code, this is a lot of code, this is a heavy, code heavy operation. You need to make sure your code can be seen by others, can be validated, approved by others, so that your machine learning model can be approved. It will be a part of a machine learning model approval, right? And this is code heavy and DevOps heavy. For this reason, for that, because you need to have certain environments, the environment between different scientists are much larger than the environments between data engineers. Chances are, if you are data engineer, the whole team will use a similar data engineers, environments, because data engineering, the least thing you want to do to have is unpredictable. Is if it's unpredictable. If there are accidents happen, that's the worst nightmare you will have as a data engineer. You want everything to be predictable. You want everything to fall into your expectation, which is exactly the opposite of a data scientist. You want to, as a data scientist, you want to discover new things. You want to have something that you completely or anybody else completely unexpected, right? So your environment, it will be different. Your package, your software package will be different, and even the house, the projects, the Spark pool, the computers that you run will be different. Maybe with GPU, maybe with something else, right? So in order to make sure, but then once you have the project, once you get your machine learning model ready, you would expect other people to use the same environment as yours, right? You don't want to, because you don't want people to run your code with a different environment and get different result. A very common thing is once you have a new code for someone else, you tried it out. Let's talk about in Python scenario, that the first thing you want to do, you want to import. What does import mean? That means you don't have the same library as that person, the original author has, right? So you want to make sure you have the same power. You want to have the same software. You want to have the same package, and you want to have the same hardware, the same type of GPU, the same type of storage. This is how what the environment define. Environment can set up the boundary of your software and the hardware and make sure that your setup is consistent within the creator and the user, and people can collaborate with other team members. So environment will define the software library and the hardware or compute. Here you can see up here you have a library. You can define public libraries. I'm using pandas. You use MATLAB. Someone use Seaborn. All these public libraries, and you can upload your own class files as a custom library. Right, so these are libraries, software environments. Then storage, you can store some resources, some small files, configuration files, for example. That is Spark Compute, which defines the pool. Again, we see those node family, number of nodes, how many worker nodes you want to have, right? Spark driver core, and what's the version, what's the memory, etc., etc. And Spark properties, other like segmentation or something like this. So this is how you will define the environment for each machine learning. How you ensure people are actually utilizing the same environment as you, so that they get the same result as you. With a notebook and the machine and the environment, this is the compute. Now, once you get but the machine learning is more than running a job. So once you create some kind of hypothesis, you create your own model. You have to run it, test it, train it, test it, and if the training result comes out, you need to calculate the metrics to make sure, for example, it is accurate against a certain test sample. Then after that, you will post that in a certain place with registrations so that people can come to you and can get to that catalog uh, and utilizing your model, just like a data product, right? So there are frameworks that people use for this purpose to define what you need in order to define such in order to go through this experimenting and model publishing process. So ML Flow is one of those. ML Flow is an open source platform that helps you manage the whole life cycle of machine learning. It starts with checking. It allows you to record and compare experiment parameters. So once you start and the results, once you start a run, once you create your notebook, you run the notebook, the result can be registered to something called an experiment. Experiment. Once you have a multiple experiment with both testing, training, and testing, you like one of them, you can package that into a model. This model is the official published product that people can use, where you can let people use that, and it also defines certain code structure, which helps improve the reproducibility of your product, of your model. And of course, it helps you manage the dependencies, including the libraries that you will require and something else, and a lot of configurations. More than that, it starts with experiment, right? You get a notebook. You will define a notebook within with a ML model code. You will run your experiment from the notebook, and you will record run results and publish runs as models if you like them. So on the upper right corner, we have the code with ML flow start run. We define the experiment, then we start running this. As we run this, we log the parameter. First of all, of course, you get the parameters. You bring in parameters to the model, right? You define a model parameter for this model run. After you run, after your training and testing, you will get some metrics such as accuracy. Now, between line 7 and line 8, this is where you are supposed to put all your machine learning experiment testing and the training and testing. I skip this all part. So it starts directly with logging the parameters I bring in. Then it just directly goes to logging the accuracy. Here I hard coded to 0.89, right? But in reality, you should insert your machine learning code in between line 7 and line 8. And the end of result is on the bottom right corner, where you see the metrics logged, run parameters logged for this particular run. And you can foresee if you run 5 or 10 versions, each of them you can compare their parameter and their metrics and identify the most accurate one or the acceptable one, whichever you like. Then once you are done with this, you will pick your favorite versions of experiment and publish this as a model. And everyone else not can see it. And actually not everyone else. It's the selected field that you provide access to. With parameters and metrics, the user can to pick the best fitting one. And ML flow, to be exact, the Fabric data science the interface also provides you with the code to invoke the model. So this will be the code. If I'm done with my model and I publish that, I will publish this code too, so that you or him or her, or he or she can copy this code and start running this code to actually connect to my model, utilizing my model. This is the only time in St. Peter's University that the copying is encouraged, right? With that, we formed the whole machine learning ML flow model that's fitted into Fabric data science. you will have a problem, you will start a discovery process. And this process, actually, the whole part is the discovery process, right? You will come up with hypothesis. You will do experiment, and you prepare the experiment, you start running the experiment, and come up with a model. You evaluate that it doesn't work. In most cases, it doesn't work. It's not accurate enough. You explore again until you like that experiment. You publish that to a model. Then you have some more enriched and operationalized, such as making it look better and put in like security things, and someone else will use your model for their insight. So this is the whole ML flow model that Fabric Data Science used. As you can see, right now, Fabric Data Science is still limited, very limited. That in that it can only use notebook. You can also utilizing like machine learning AI services from Azure, but you have to explicitly call this API. So it's the same as what you would do in Spark if you are utilizing Spark or you're writing your own Python code. But we do expect in the future, Microsoft will gradually add these API Connect points to to both data science notebook and data engineering pipeline so that these can all be utilized. And so machine learning studio is actually a byproduct is a second priority product in Microsoft, in my opinion. So that's eventually Microsoft will try to merge this product into some integrated platform, because this machine learning studio, like we just said, is another data processing pipeline. There's no reason that it should be separated from others. Eventually, Microsoft will want an integrated interface for every operation involving data. This is what Microsoft has been doing in the past 2 decades, 3 decades, and this you would expect them to do the same in the future, which is they will try to merge machine learning studio and the fabric data science. Whether which way it goes. Right now, looks like it's this way that they are moving into fabric data science. But don't be surprised if anything change, because but either way, you know what they are built on. You see the similarity and you know the difference. So you wouldn't be surprised at the work when you get your new job. Okay, so with that, we talked about Microsoft AI, Microsoft AI, Azure AI, and Fabric Data Science. Let's provide a little bit insight into AI startup. So a lot of people will ask us AI startup where to work on, and I don't have an answer either. I'm trying, but some of my thoughts I would like to share here. I think AI startups should start with traditional industry, and it cannot start from computer heavy computer heavy industry or information industry, because all the data, you don't have all this data comparing to Amazon or Microsoft or Google. All the data belongs to these guys. So you don't when you are facing consumers, they can do everything, and they can do everything they want, and there's no way you can compete against them. Outside out of these three, Amazon, Microsoft, and Google, I think Microsoft has a better approach, because at this point we really don't know where the next AI breakthrough will comes in. So the only thing you can do is to try, and there will be a lot of laughable mistakes. There will be a lot of laughable products or implementations, but eventually the real breakthrough comes from these tryouts. But who has the most grassroots tryout? That's Microsoft. That's Microsoft with its Office tools that everybody's using. And I would assume maybe 70% of the people are utilizing these Office tools. Everybody's using, everybody's trying. Out of this 70% of the population, that's where AI will comes from. and the AI breakthrough will come from. But where would that be? It will be somewhere that is currently labor intensive. I can give you three examples of what people have been doing. The first one is the insurance sign up process. In the company, in the health insurance company, where it used to take 17 steps, 11 teams, 17 steps to sign up one member, because there are a lot of things you need to do. You need to get these people. You need to investigate, validate there is such a people, validate the driver license, and validate the past history. Make sure he or she did not have a fraud history. Then you compare, you do all those medical record checking, right? So it takes 17 steps from 11 teams. What's the result? A slow and painful process for everybody. So this is one thing that I was involved in enhancing in smoothing up the process. By the time we finished, we were able to reduce half of the process. Right. So this is not artificial intelligence, but it's data related. Data related, the automated, automation related. This is an example of what you can do. The second scenario is about security monitoring. Now we all see like Hollywood movies where there's a huge room, huge with a big wall of TV sets, and some security guy just looking at those TV sets, try to identify whether there's issues. Well, just like as in Hollywood movies, right? And this is actually what's happening in most of the security monitoring thing. But the difference is in real life, no security has the power to monitor 24/7 or even just 5 by 8. People will get tired. So the monitoring in most cases is only used for back checking. So if something happened, okay, let's get back and look at what's happening with the monitoring recording. Now, a friend of mine actually come up with the idea and start a startup by enhancing the security monitoring by cognitive service. It does not have to be real issue. All it does is to monitor there's a sudden change in pattern. If at night there's suddenly a brightness moving, suddenly there's a dark shade coming out, or suddenly a machine some computer starts up and making noises. These are dangerous signs that it will notify the security guy, ask them to monitor. So this is used to be labor intensive, but with this help, the monitoring side, the warning side can be reduced to maybe like 1% or 0.1%, right? And the last one is fashion design. There's the fashion design. How about a large language model that if I'm designing a clothes or a handbag, I said I want to 70% Louis Vuitton or and 30% of Gucci. And if you think about it, what is fashion design? What is fashion? Fashion is the pictures, is the dots and and the lines, curves, and the colors. These are perfect. These are perfect use case for pattern recognition, right? But nobody thought about it until someone I actually see that in one of the AI startups symposium, and someone's utilizing this for the fashion design. But there are also issues with this. Is mostly is a copyright. If you are you are doing your the fashion design, but knowledge base based on what people have already been designing, sooner or later you will run into something similar to what people have been designing, right? So this is an interesting thing that you may be thinking of.